Welcome back. Today we're going to be talking about functions. Okay, so you might have heard this word before, and so let's define it formally. A function is just a rule, right? It's just a rule that, what we've been dealing with when we talk about equations. It's a rule that assigns to each input only one output, okay? So the values that goes into a function is called the input, and the value that results is called the output. And we're going to talk about this and clarify this a little bit more in the lesson today. One way of showing a function rule is using a mapping diagram. So the mapping diagram shows, typically it uses ovals to indicate the set of numbers that are considered the input set. And it uses one-sided arrows or rays, right, where the ray generates or begins at a certain number and it's brought to another number. Okay, so the input is in one oval and the output's in another oval, and the rule that assigns each input to one output is shown by the arrowhead here. So for instance, this is saying that 1 becomes 2. The input of 1 becomes the output of 2. The input of 7 becomes the output of 6. And the input of 3 becomes the output of 8. Now, we could maybe try to find an equation that relates these two things, but this is a more general idea of a function where it's just a way, like the rule here is just defined by the arrowheads. Okay, so if I made ordered pairs here, I'd have the ordered pair 1 goes to 2, okay, 3 goes to 8, and 7 goes to 6. Now, the one thing that I'm checking here is that each number in the input gets sent to only one number in the output. Okay, that's what makes this sort of relationship not only just a relationship in general, but also a function, right? That this characteristic is satisfied, that each input is only one output, okay? All right, so using the mapping diagrams here, let's see if these satisfy that rule. Okay, so are the relations below functions? Well, let's look at this. So the input is here, and I can tell it's the input because it's where the ray begins, right? This is the beginning of this line that's being sent to 3, and this is the output. And similarly, this is the input, and this is the output. Okay, these two things are relations? They're relating one number with another number, but are they indeed functions? Okay, so some relations are functions, but not all functions, or all functions are relations, but not every relation is a function. So to determine if these relations are functions, we have to really just think about the idea is if each input is sent to one output. So for instance, 7 is sent to 3. So 7 isn't being sent to two different places. 7 is just being sent to 3. And if I made a coordinate pair, the input would be 7, the output would be 3. Okay, 8 is being sent to 1. Okay, 9 is also being sent to 1. And 10 is being sent to 2. Okay, so in this situation, the output of 1 gets generated by 2 separate inputs, and that's actually okay for a function. It's okay that 8 goes to 1 and 9 goes to 1. It's not okay that 8 would go to 2 different spots. So think of it this way. Think about your inputs as students and your outputs as rooms. Okay, it's not okay for me to ask like 8, like a student, to go to 2 different rooms at the same time, right? So let's say I'm asking it to go to, room 211 and 232. Well, you can't ask one person to split themselves to go to 2 different rooms, but you can send 2 students or 2 numbers to the same room, right? So I can send both 8 and 9 if they were students to the same room, but I can't have an error that generates at 8 and goes to 2 different spots. That's not allowed with a function. Okay, so if you look at the next case, this is actually an extreme case where 3 gets sent to 0, and 3 also gets sent to 2, and 3 also gets sent to 4, and 3 also gets sent to 6. So this is actually absolutely not a function. Even with just these 2, it wouldn't be a function because you're sending it one input to multiple different outputs. And the rule for a function is that every input gets matched with only one output. It's okay if one output comes from two different inputs, but it's not, this situation is not okay. If you put them in ordered pairs, you can also see in ordered pairs, if you have a repeated first term in an ordered pair, it means it's absolutely not a function. So right here, even just with these two ordered pairs, this is not a function. It fails it right there. Okay? Okay, so if we want to identify functions by tables, now tables are just, imagine that tables are just a different representation of your mapping diagrams, right? We could create a mapping diagram from these tables. So for instance, this would be our oval of our input, 5, 10, I have to make a bigger oval here. So 5, 10, 15, 20, and 25. And this right here would be your output, which is, 7, 6, 15, 2, and 15. And I could map, 5 goes to 7 and so on, right? But we could also just, 15 goes to 15, which is also okay. It just goes to itself. And 25 goes to 15. So here you can really see that each input is paired with exactly one output. So this right here is a function. This relationship between inputs and outputs is also a function. Okay? Whereas this one, so 1 is being sent to 10. So think about your input diagram here. 1, 5, 4, and then you have 1 again, so you don't want to represent it at, twice. You don't want to put 2 1s here because it's already been represented here. And 7. Okay? And we can write the numbers 10, 8, 6, 4, and 2. So 1 goes to 10, 5 goes to 8, 4 goes to 6, and then you have a situation here that 1 is also being sent to 4, right here. So, and then 7, finally 7 is being sent to 2. Well, the idea that you have 1 being sent to 10, and you also have 1 being sent to 4, makes this not a function because this one input is paired with 2 outputs, and that's a problem. Okay, so this is not a function. Okay, so we went over how to identify functions with mapping diagrams and tables. And finally, if you have a graph, let's see if we can figure this out using a graph. Now, the input for another way of saying the input is it's the x variable. So I can put input down here, and this right here is the output. Okay. So remember, one input has to be matched with exactly one output. Okay, so here, this is the coordinate. If I were to write, if all these points represent the relation, and I'm trying to figure out whether or not it's a function, I could write them all down, right? The first coordinate is 1, 70. The second coordinate is 270. Again, that's okay. 1's being sent to 70 and 2's being sent to 70. It's okay if an input comes from 2 separate outputs. That's still a function. But here, this is 285, right? So it's 285. This graph should actually have a break in it because it seems to start at 65, which means that there should be a little squiggly line here to say that, that it's not going up by 5s until you get to 65. Okay, this is 285, but 2 is also paired with 70. So if you think about what that looks like, that would be 2 going to both 70 and 85, if this was the mapping diagram, okay? So this second point right here is a problem, all right? This point makes the entire relationship not a function. There's actually a second point that's a problem here. So look at these 2 points right here. These 2 points both have an input value of 9, but separate output values. This would be 9, 95 and 9, 90. So right here, it was enough that we had 2 coordinate pairs here that had the same input value, but again, there's another set of pairs that are our problem. So it's absolutely, this is not a function. And we can actually see that if the ordered pairs on a graph, if any of the pairs or any of the points that are part of the relation fall along a vertical line here. So these fall along this vertical line right here. Oops. And these fall on this vertical line. If they fall, these 2 pairs, if they fall along this line, it means they have the same x coordinate. right? Because any of the ordered pairs along this vertical line have the same x-coordinate. That means that the relation is not a function. So what we can actually do is we can actually take a vertical line and use that as a way to check if the relation is a function. If we draw a vertical line across all the dots, if at any point in time these dots have two things that are all along the same vertical line, it means that the entire relation is not a function. Okay, this is actually what we call the vertical line test. Okay, is what we do is we take a vertical line and we bring it across the points that are part of the relation and see if at any point in time 2 points are collinear with this vertical line. Okay, and you can see it here and you can see it here. That's a quick visual way to check to see if a relation is a function, because if 2 points lie along the same line, they have the same x value. If they have the same x value, it means that two separate x values or input values, or two of the same input values, are sent to two separate output values, which makes it not a function. Okay, let's try it one more time here. So this is the height and weight of basketball players, or of a team member. Let's create a vertical line right here and see what happens when we pass this vertical line over the set of points that are part of this relation. Okay, so here there's not a problem. This x value here of, let's see, this would be 68, has only one y value of, again, there should be breaks in these graphs here. Okay, it looks like these are going up by, this is 160, and this is 180. So this is actually probably a female basketball team, because the male teams are way more than, our biggest weight here is 190. So, so this point right here is fine because there's no point that's collinear to it along a vertical line. But right here, these 2 points right here are a problem because they have the same input value. They have the input value of 70. So we have 70 going to, it looks like about 163. And we have someone with 70 also weighing about 175. So right here, it's not a function. And furthermore, there's two other points that are also in conflict. Right here, the height value of 70 goes to 170 and also goes to about 185. So this right here is not a function. We can tell by writing the coordinates down, and it also doesn't pass the vertical line test. Okay, so that's exactly, this is the end of the lesson for today. All we're learning about is the definition of a function and how we can tell a function from a mapping diagram, a table, coordinates, or a graph, right? Thanks.